Welcome to FrontEndSystemsLab. This is a channel where we explore what's really going on under the hood of modern web development. Today, we are exploring the world of TypeScript. In today's episode, we learn we are going to have to stop trading application speed for type safety. For years, we've accepted a strange compromise in modern TypeScript systems. We write clean, elegant interfaces that describe our data perfectly. Then we immediately abandon them at runtime and rebuild the same structure again using validation libraries like Zod, Yup, or Joy. And the result is always the same: duplicate logic, duplicate maintenance, and a growing performance cost hidden inside every request and every bundle. Today, that trade-off is being challenged at its core. With the new TypeScript 6.5 macro system, we are starting to see a shift where runtime validation is no longer something we manually construct. Instead, it can be derived directly from the type system itself during compilation. In other words, validation stops being runtime code you maintain and becomes build time output the compiler generates for you. Let's break down what that actually means in practice. First, we need to understand the real problem developers have been living with. Imagine you define a simple type in TypeScript. Type user equals an object with an id as string, a name as string, and an email as string. This is your single source of truth. It is clean, it is precise, it is what TypeScript is best at. But the moment this data enters your system from an API, a form, or an external service, you no longer trust it. And rightfully so. TypeScript types disappear at runtime, so you rebuild the same structure again using a schema. You end up writing something like a Zod object where id is a string, name is a string, and email is a string with email validation. Now you have two representations of the same reality. One exists at compile time. One exists at runtime. And this is where systems start to degrade, because now you are maintaining two parallel definitions of the same data. And they drift. They always drift. Someone updates the TypeScript type and forgets the schema. Or updates the schema and forgets the type. And suddenly your single source of truth is no longer single at all. It is duplicated truth. And duplicated truth is just inconsistency waiting to happen. This is the hidden cost of modern validation systems. Not just bundle size, but structural friction. Every new model requires two implementations. Every change requires two updates. Every API contract becomes a maintenance point. And as systems scale, this becomes significant. Not just in developer experience, but in performance too. Validation libraries ship into production. They parse, check, allocate, and execute logic that your type system already knows at compile time. So the question becomes simple. Why are we paying runtime cost for information the compiler already understands? That question is exactly where TypeScript 6.5 macros enter the picture. The macro system introduces a new idea. Instead of treating types as static descriptions that disappear after compilation, we can attach transformation behavior to them during build time. So instead of writing a type, then separately writing validation logic, we can define the type once and allow the compiler to generate the validation layer automatically. Here is the conceptual shift. You define a user type as usual. Id string, name string, email string. Then you annotate it with a validation macro, something like validate. At compile time, TypeScript expands that definition into real JavaScript validation code. What gets shipped is no longer a schema library. It is not Zod, it is not Yup, it is not a runtime dependency at all. Instead, it becomes a plain function generated by the compiler that looks something like this. A function that takes data, checks whether id is a string, checks whether name is a string, validates email format, and either throws an error or returns the valid object. No abstraction layer, no runtime schema system. Just direct code derived from your type. And that changes everything, because now validation is no longer something you design twice. It is something you define once, and the compiler becomes responsible for keeping runtime behavior aligned with static types. This is where the real architectural shift happens. TypeScript stops being only a type checker. It starts becoming a code generation system for runtime guarantees, and that collapses an entire category of tooling. Libraries that existed purely to solve the gap between compile-time types and runtime safety begin to lose their necessity. No more manually maintaining schemas. No more syncing DTOs. No more duplication between backend and front-end validation layers. But more importantly, no more validation overhead shipped into production as generic library code. Because now, validation is compiled specifically for your types. Nothing more, nothing less. This is where performance gains appear naturally, not through micro-optimizations, but through removal of entire dependency layers. Instead of importing a validation library and executing generic logic at runtime, you execute direct code that was generated specifically for your data structure. There is still an important limitation to understand. This system works best when your data structures are statically defined and predictable. It does not replace all dynamic validation patterns. If your validation logic depends on runtime conditions or user-defined rules, you still need runtime logic. But for a large portion of modern applications, especially API-driven systems, form validation, and shared front-end back-end models, this covers the majority of real-world cases. And that is why this change matters, because it is not just about removing a library. It is about removing a pattern that developers have relied on for years, a pattern where correctness requires duplication. We are moving toward a model where correctness is derived automatically from the type system itself. And that leads to a deeper question about how we build systems going forward. Instead of asking how to validate data safely at runtime, we begin asking how to express data so that the compiler can guarantee correctness before runtime even exists. That is a fundamentally different way of thinking about software. And if this direction continues, we are going to see fewer runtime abstractions, smaller bundles, and tighter alignment between what we write and what actually executes. Less duplication, less overhead, more trust in the system itself. So the real shift is not just TypeScript gaining macros. The real shift is moving validation out of runtime entirely and letting the compiler take responsibility for a problem we have been solving twice for years. And once you see it that way, going back to manual schema duplication starts to feel less like engineering and more like unnecessary overhead. Thanks to you for watching FrontEndSystemsLab. Please subscribe for more under the hood content.